In this next series of videos, I'll be looking at topics in arithmetic. So I'll kind of lay the foundation to continue with topics in algebra. So you can consider this as maybe some mini courses in, one mini course in arithmetic, maybe a mini course in algebra. The only thing I'll assume is you have a decent foundation in operations with whole numbers, sign numbers, and just a little bit of fractions, even though we'll cover some of the basics in those topics also. Let's look at some of the things that I need for you to know. Natural numbers. Okay, the natural numbers consist of the set of numbers which include 1, 2, 3, and so on. Okay. Let's look at the set of whole numbers next. The set of whole numbers consists of all the natural numbers, including now, I simply had 0. So it'd be 0, 1, 2, 3, and then it continues forever. Okay, that's the set of whole numbers. And of course, the integers includes all the whole numbers, and then the negatives of the natural numbers. So this would be for integers. That would be 0, 1, 2, 3, and then it continues. And on the other side, you'll have the negatives, negative 1, negative 2, negative 3, and so on. Okay, so natural numbers, whole numbers, and integers. Should be familiar with those sets of numbers. Now, by definition, a prime number is a natural number greater than 1 that only has 2 factors or 2 divisors, and that would be the number itself and 1. Okay, so it's a natural number larger than 1. So the next number larger than 1 would be 2. And that only has 2 divisors or factors, 2 and 1. The next one would be 3. 3 and 1. 3 times 1 is 3. Only 2 divisors or factors. The next one, 4, would not be 1 because that would have 4 is divisible by 4, 1, and also by 2. Okay, so 4 is left out. The next one would be 5. Factors or divisors are 5 and 1. 6 would not be because 6 has divisors of 6, 1, but it also has divisors of 2 and 3. Okay, so we got the 6. The next one would be 7. The only divisors of that would be 7 and 1. Okay, 8 would not be a prime. 9 would not be a prime. 11 would be. 12 would not be. 13 would be. And so on. Okay, so you can kind of figure out what those would be. Those are the prime numbers. Now, one of the first things I want to look at with you is what is called prime factorization. So, for example, I have 60 here, and it says prime factor each of the following. So that means by prime factor, we may express the number as the product of prime factors only. Okay. So in other words, you can express 60 as 30 times 2, but 30 is not a prime. Okay, so you can't factor into 30 times 2, but again, 30 is not a prime, and so on. So one way we can do it is just take the 60 and then divide it by the smallest prime that would divide it. Okay, so again, here's your list. So the smallest prime is 2, so we divide by 2. 2 into 60 goes 30. And then you continue. Divide 30 by the smallest prime. That will divide it. We always start off with 2 and then go on to 3 and 5 and so on. So we start with the smallest one first. So, okay, 2 into 30 will go 15. Okay, you can see 2 is not going to divide into 15 because it ends in an odd number. Okay, so The next one we try is 3. 3 will divide it. 3 into 15 will go 5. And then smallest prime that would divide 5, of course, would be 5. That would go one time. And then we stop there. That's as far as we can go. Okay, so if I multiply these numbers over here on the left side, the 2 times the 2 times the 3 times the 5, that's going to give me 60. Okay, so that's the factorization. So I can go ahead and delete these. And then I can express 60 then. The prime factorization of 60 then would be 2 times 2 times 3 times 5. Now I'm going to introduce a little bit of algebra here, and you don't have to do that at this point, but I'll go ahead and say, well, I'm going to express 2 times 2 as 2 squared. And just, again, the exponent, the 2 is an exponent, and it's simply saying that the base, which is also 2, is used as a factor twice. So it's, when I write 2 squared, or 2 to the second power, that's the same thing as 2 times 2. Okay. So just a little bit of algebra there. Okay, so that's the prime factorization of 60. Go to the next one, 36. Okay, 36. On a prime factor, so we again divide by the smallest prime that divides it. In this case, it's going to be 2. So divide it out. 2 into 36 will go 18. Divide that out by, again, 2. Smallest prime that divides it. This will be 9. Smallest prime that goes into 9. 2 does not divide it, but 3 does. 3 into 9 will be 3. Smallest prime that divides 3 is 3. And that would go 1. And then these factors right here, these numbers right here, are the factors that multiply to give you the 36. So that would be the prime factorization of 36. 2 times 2 times 3 times 3. Clear this? And then I would write it this way. 36 then is 2 times 2 times 3 times 3. And again, since I have two factors of 2, I can write that as 2 squared. Since I have two factors of 3, I can write that as 3 squared. Again, either way here, at this particular point, okay, we just want the factorization, so we could give either that answer or this answer. Okay, the next one we want to do is 98. Take 98. And again, the smallest prime that divides 98, we see that it ends in an 8, which is even, so I know it's divisible by 2 again. So divide by 2. This goes 49. Okay, with 49, 2 won't go into it, 3 won't divide it, 5 won't divide it, 7 will. 7 into 49 is 7. And the smallest prime, obviously, that divides 7 is 7. This goes 1. So 2 times 7 is 98. That's the prime factorization for that. There we have it over here. Okay, 98 is the same thing as 2 times 7 times 7. And then again, because I have two factors of 7, I can write that as 7 to the second power, or 7 squared. So what we're doing is just prime factoring a number. Okay, so this is going to lead to, or we're going to use this procedure in the next video when we get into reducing fractions. Okay, and you'll be doing the same type of procedures when we get into some algebra topics. Here it is. Okay, 88. We want to prime factor 88. So 88 is obviously divisible by 2. This will be 2 here. 2 into 88 will go 44 times. Again, we divide 44 by the smallest prime. We divide it. Again, it's going to be 2. This will go 22. 22, the smallest prime that divides it is 2. This will go 11. 11 is a prime, so the smallest prime that divides it will be 11. Let's go 1. So the product of these numbers on the left side then is the factorization. 2 times 2 times 2 times 11. Okay. So there's the factorization. 88 is 2 times 2 times 2. That's the same thing as 2 to the third. So I can write that as, again, 2 times 2 times 2 times 11, or 2 to the third times 11. And again, if I go too fast in some of these, just pause the video and rewind. Clear this. 325 is the next one. So 325. The last digit here, or the first digit here, is not even, so it's not divisible by 2 here. 3 won't go into it. So try 5. Okay, this will go 65 times. Smallest prime that will divide 65, it ends in 5. No, it's not divisible by 2, it's not divisible by 3, but it is divisible by 5. So that goes 13 times. Smallest prime that will divide into 13, of course it's 13, because 13 is a prime. This will give me 1. So the factorization then, prime factorization for 325 would be 5 times 5 times 13. Okay, 5 times 5 times 13, or because we have two factors of 5, we can write that as 5 squared, so 5 squared times 13. That's the prime factorization. Okay, so that concludes this video. Like I said, we'll continue with more topics in arithmetic in the next video. So take care, and thanks for watching.